So in this lesson, we want to look at the particulate nature of matter. So when we talk about the particulate nature of matter, we are trying to talk about the matter itself. Matter itself has been broken down. Then when this matter has been broken down, we'll then look at the particles. So when we study the particulate nature of matter, we are studying matter but at a particle level. Saka at a particle level yedu iyi ndo yatakuda kutanga nayo yate tichiti what is an atom. So an atom, by the general definition, it is the smallest particle of an element that takes part in a chemical reaction. Are we together? So an atom, that's the smallest particle of elements that take part in chemical reactions. So you have to include all these three aspects. The aspect that it is a smallest particle hatikwanise kuzobreaka this atom richibva raita tumwe tumaparticle again. It is its smallest unit. Then it is supposed to be a smallest unit of an element. An element, that will be a group of atoms of the same kind that takes part in a chemical reaction. So when a reaction occurs, tikutaura isusu kuti chi ma-atoms edu ndo ari kuparticipate in that reaction. For example, waona maybe sodium hydroxide yasangana iyo ne-hydrochloric acid in a reaction ndizvo zvere. That reaction of those two chemicals anoitika nekuda kwema-atoms, because the atoms are the ones that are participating in the reaction. So for the reaction to happen, an atom is the one that is making that possible. And it saka, since an atom richita make possible such reactions, it is good for us kuti tikwanise nge tichinzwisisa atom redu to the core, kuti muatom medu chii chiri kukonzeresa mareaction. Everything chiri pastructure yeatom redu unofanira kuchinzwisisa kuti chinoparticipata sei, such that overally we then have chemical reactions happening or chemical reactions taking place. So the next point is that atoms are made up of, number one, we have the nucleus, which is the center. So the nucleus yedu, that's the center. If you look at that diagram here, the nucleus yedu, that's the center. But the nucleus yedu is the center of the atom yedu. The nucleus yedu in it two things that are found within it, right? We have the proton and we also have the neutron. So we have these two things nucleus medu is the proton and the neutron, and these two things, they are called nucleons. Anonzima nucleons, why? Because they are found in a nucleus. So if we are to then look at another point, tinema electrons edu. Electrons edu, they are moving around the nucleus. So around the nucleus here, we have this line. And mind you, ukatarisa pane diagram rangu iri ndizvo twasa twakaita tuma dotted lines, right? This line around the nucleus redu, it's called an electron shell. Saka within the electron shell, that's where we find my electrons edu achita move around. So isusu pekutanga, on our first slide, we are saying an atom is the smallest particle of an element and that takes part in chemical reactions. Saka taudzwa izvozvo tobva taudzwa again kuti an atom redu structure yaro pekutanga rine a nucleus which is at the center, and then in this nucleus there are protons and neutrons, and outside the nucleus we have an electron shell. Saka pese paticha study the particulate nature of matter, we have to study, number one, how are the electrons going to be moving around. Ndiro zvere nekustudywa kuti what is the proton doing and also what is the neutron doing. So let's go to the next slide. So as you can see ndizvo zve, these electrons atachitaura tune ma dotted lines pa diagram rako. This electron shell rine ma dotted lines munonge mune ma electrons medu ndizvo zve, is actually represented in this diagram here, whereby tukuti pa center pedu pe red up ndo pane the nucleus, and but pane the nucleus electrons edu, for example tikatora re green iri ndizvo zve rinenge richimove around this in its what, in its orbit. Are we together? Then re blue tikaritora iri rinomove around in its what, in its orbit, and it then re yellow rinomove around in what, in its orbit, and it in other words trukuti pakati apa there is space, and there is space iri within pakati apa ndizvo zve. Then ma electrons aya anenge akuholdwa because of zvinhu zvirimo mukati zvinonzi ma protons. I think we'll look at it later on, but chikuitika ndechekuti ma electrons aya nepane ma nucleus yedu there's some space, and then these electrons are kumove around their space inenge ichinzi what, an electron shell or an orbit. So we can see clearly ndizvo zve that ndo zvine zvichiitika. And so let's say for example you think of an analogy like a tiny solar system, and we all know that we have the sun ndizvo, and then the sun redu zvinonzi izvo planet earth ndizvo zve, let's say kuti earth yedu iyi, it rotates around the what, the sun. Are we together? It is rotating around the sun, not the sun rotating around what, the earth. So that's the same nature inongoitikawo futi ndizvo zvere. The sun ndoyata kuti ndo nucleus yedu, and then the electrons are rotating around, but they are rotating around in their orbits. Then toenda pane, if we are to break down the particle redu re atom ndizvo zve, if we are to break it down, it comes up ne 3 particles anenge aripo. We have the proton number 1, and we have the neutrons number 2, and we have number 3, the what, the electrons. So we have 1 proton, 2 electrons, and 2 neutrons, then 3 electrons. Are we together? Then ma subatomic particles edu aya atete now, the 3 subatomic particles, though the ones are true, they consist of the what, of the atom, and then ma subatomic particles edu, they have ma features anenge ari paari. For example, the first feature is the charge treatise. Yatinoti charge yedu, it's either you have something positive or you have something negative, or you have something that is not positive, is not negative, is not charged, which is what, zero or neutral. So my protons edu, they have a positive, then my neutrons edu, they are neutral, they have 0, and then my electrons edu, they are negative, they have -1. Saka pa ma charges we have my protons nema electrons edu ari iwo anema charges, and it then toenda pa relative mass. The relative mass we are saying kuti chinorema sei, and it so our protons edu ane a mass of 1, then my neutrons edu ane a mass of 1, but we have this mass yema electrons yedu, it's 1/1836. Sometimes unokwanisa iona yakanzi 1/18 what, 40 in other textbooks, and it saka ukatoi divide yo kati 1 divided by 1840 unobudisa 0.0000 something treatise. So in other words, it's nearly 0. Tiri kunzi taita approximate to maybe 2 decimal places, the answer will be what, 0. So we would say that an electron in a what is known as what, negligible, it's negligible mass. In other words, trukuiti negligible mass because it's mass yekuti we can't consider it when we are adding my other masses. So at the end of the day, what then happens is that mass yedu yema-protons ndizvo zvere nema-neutrons is the one that will be considered as the overall mass yeatom redu, which will be the relative atomic what mass. Saka the mass yeatom redu tiri kuti tingoedha just what protons and neutrons tobva tatowana the what the mass yedu. And then we have location. Location yedu ndo kwazviri kuwanikwa uko tritezi. Saka ma-protons edu ari kuwanikwa munucleus, ma-neutrons edu ari kuwanikwa muchi nucleus. Mind you, pipe ndambotaura kuti these ones are what we call what nucleons. Are we together? They are nucleons because they are found in the nucleus. Then we also have my electrons. Electrons, as we have said earlier on, they are found in what? In electron shells. And electron shells cannot anowanikwa munonzi machi ma orbits. These orbits are sometimes called what? Energy levels. Are we together? Saka that is where electrons are found. Then my key facts are protons and neutrons are in the nucleus. Then electrons move in shells or energy levels around the nucleus. Then the last one is that the mass of an atom is equal to the mass of the nucleus. Yana ndichitaura yaya yekuti the mass of the nucleus yedu tiri kuti ma protons plus ma neutrons. Are we together? Then ma electrons anowanzoya achibvunzwa reason kuti koma electrons, why is it that they are not considered as part of the mass? And the reason is that they have a negligible mass. That negligible mass is a very small what mass. Saka that mass iyoyo it is not considered. Saka inongosiwa yongonzi haina basa. Then we look at atomic number and mass number. So if we are to look at a periodic table, we will find out tine something like this. This symbol, we have chibox chedu ichichi. Then taita chibox chedu, we have a big letter which will be the symbol of the atom, and we also have another letter A and another letter Z. So this letter A ndizvo it represents what? It represents the nucleon number. It's a number that we'll see. Saka kana pese patinetaona pangonzi nucleon, it means is what? Neutrons plus protons is those things that are found within the what? Within the nucleus. Then proton number, we are talking of the number of what? Protons, which is equal to the number of electrons. So now let's look at our notes. First point, the atomic number Z is the number of protons. It defines the element, e.g. all carbon atoms have 6 protons. Are we together? Saka ma elements edu kuti afanane kuti anzi they are of the same element. It means that they have the same atomic number or the same number of protons. Ndo kuti timataura kuti this one is an element ye carbon. Ndizvo unenge wati one atom rimwe recarbon rine 6 ma protons, then rimwe atom recarbon rine 6 ma protons. Then we have the mass as a second point. Mass A. Mass yedu is the number of protons plus neutrons. And it ndo yatachitaura yaya kuti ndo inonzi nucleon what? Number. Are we together? Which is just the mass of what? The protons plus the neutrons. Then we also have a neutral atom. A neutral atom now ndizvo tukureva kuti atom redu kana riri in a state yekuti the number of protons are equal to the number of electrons, which is the thing it must be like. Tichireva kuti ma protons edu are positive. So let's give maybe an example. Toti ma protons edu is 7. Saka inotibuditsira chi plus what? 7. And because my protons they are positive, then tobva tati ma-electrons edu they are what? They are 7 again. Tritese ma-electrons edu it's minus 7, and it. So if we were to work out this mathematically, tikati plus 7 minus 7, answer edu is equals to 0. Saka that's when we get a neutral atom. Tritese. Saka questions mwezenguwa in exams it comes ichitaura kuti iyo why is an atom electrically neutral? Are we together? The reason why an atom is electrically neutral is because there is an equal number of protons and electrons. Saka number of protons is equal to number of electrons. Therefore, it now becomes electrically neutral. They cancel out. Positive charge yema protons yedu ino cancel out ne negative charge yemachi yema electrons. Therefore, we get a 0, which is a neutral. Then tochimbotarisa maybe an example ye atom yatrukuwa namba ma periodic tables and it. Then for the first example I took sodium dirum. So pa sodium pedu you find out there are two numbers that are there. We have 23 pamsoro and we have 11 pazasi, and it. Saka 11 yedu e ndio ikuti represent the what? The proton number. Tritese number of protons, which is equal to number of what? Electrons, and it. Then yepamsoro e iri kuti represent what? Ma number of what? Protons plus neutrons. Saka protons plus neutrons is equal to the what? To the mass. Is that okay? Then you find out kuti pane mamwe ma periodic table ekuti pamwe dzakapesaniswa, anditi. Saka iwe what you always have to know is that the mass is the what? Is the bigger one. Tritese. And then this proton number is the what? Smaller one. Are we together? So the atomic number edu or number of protons is 11, and that is same with the number of electrons. Then the mass edu is 23. Then panozoya manje ndebe kuti chitsvaga chi ma number of neutrons. So the number of neutrons edu takuti isusu mass edu e, because mass edu e yanga itori nema neutrons mukati. Titese takuti mass yedu e ine ma neutrons minus the number of protons. Saka which means tikabvisa ma protons panapa ndizvo panosara nemachi nema neutrons. Saka we'll just say the mass yedu minus what? The number of what? Protons edu. Saka teto chiti 23 minus 11, then we get what? 12. 12 becomes our answer. And it. Then for this one, let's try to also calculate the number of what? Neutrons. And so for this one, trukuti number of neutrons yedu will be equal to what? 40 minus what? 20. Then 40 minus 20, it gives us what? 20. Then ye Ag silver yedu, again trukuti number of neutrons will be equal to what? 108 minus 47. Then again ye oxygen yedu, number of neutrons yedu will be equal to 16 minus 8. Is that okay? Then to end up, and then the next part is the revision. So for the revision, you work out on the revision. After the revision, y itaese, then you then have to do the revision yachona iyo tobataita test, and it. So first of all, pangons, what is an atom? Generally, maybe you describe what an atom is, right? Then upper bands, atoms are made of this. Then complete the table. You have to complete the table. Then define the following terms. Properly define those terms. And then the other one, the diagram below shows the atomic structure of an atom. Positive charge chichichi ranzi what label parts what. Saka those parts you are supposed to label them, and then point out this one. This one now you are then given chinchirim periodic table, and it sanke zvatamboita an example yatamboita earlier on, and that thing chirim periodic table you're supposed to do what? You're supposed to interpret it, then nyora your things, then you're also supposed to find out to deduce the numerical value of 3 kuti 3 ambori chi, then also numerical value of 7 ambori chi, handiti. So you do your revision, then wopedza yese, then we catch out for the next lesson.